Hey there, this is Reuven Lerner, and I want to welcome you to my talk for PyCon Israel 2021. When is an exception not an exception? Warnings in Python. So let's start with an example from real life that you might be familiar with. You're driving in your car, and the arrow on the fuel gauge looks like it's close to empty. Should you get gas? Do you need to? Will you chance it? And you say, we probably have enough. Now, of course, the whole point of the fuel gauge is for you to see that it's close to empty and go get more gas. But if you're like me, then you probably say, it's probably okay. So for people like me, the car comes with an extra way of nudging us, of pushing us to do the right thing. And that is that yellow light. And that yellow light tells you, hey, dummy, don't wait. You should really be changing your behavior and you should really be getting gas now. Because if you don't change your behavior, bad things will happen. It's sort of like, what I used to tell my kids when they were little. If you don't listen, bad things happen. So it's not listening to someone, it's listening to our machine, it's being in touch with it, it's understanding what's going on. We need that sometimes in our programs. We need a low fuel light for our software to tell us if you continue doing this, it's not going to end well. And we need that low fuel light to be annoying. We need to be persistent. We need to really get under our skin so that we will actually change what we do. And that's what warnings are. Warnings have been around in Python for quite some time. Since late 2000s, it's more than 20 years already. They were introduced in Python 2.1. And the whole point of warnings at that point in time, the reason they were introduced in that PEP was because at that time they were getting ready for what they called Python 3000, what we call Python 3. And they knew that there were going to be incompatible breaking changes in the language. And so there needed to be some mechanism to tell people, hey, what you're doing is not going to work in Python 3, and to make it annoying but non-fatal. And that's basically what they did. You've probably seen warnings in your Python work already. So here's an example. First from Python 3.9, the latest version. If you go, say, from collections import mapping, you're going to get this warning message. Deprecation warning. Using or importing the ABCs from collections instead of from collections ABC is deprecated since Python 3.3, and 3.10 it will stop working. Sounds like what I was describing with the fuel gauge, right? We're telling you what you need to do. We're telling you that we've been telling you this for a while and you have not paid attention. And we're telling you that if you persist in this behavior, bad things will happen. But do we really need warnings? Right? Maybe we could use some other mechanism that's already built into Python without creating something new. So one possibility would be exceptions. I mean, exceptions are a separate communications channel, and people often think about them as a way of finding errors, but it's not just errors. They actually are used, they really are a separate communications channel that we can't ignore. One analogy that I like to use is you're talking to your friend and your mobile phone rings, and you say to your friend, hold on a second. You answer your phone. I mean, you probably don't do this, but you've seen people do this, right? They tell their friend, hold on a second, answer their phone. And then when they're done with the phone, then they go back to their friend. And that's because for those people, maybe for you, maybe for your friend, the mobile phone is not ignorable. You have to take care of it right away. And that's what exceptions are. They're a message that comes in that you have to deal with. And if you don't deal with it, then the program exits. So we can trap exceptions, we can distinguish between them with different kinds of classes, and then we can decide with try and accept whether we want to ignore them. That's the good part. The bad part is, as I mentioned, if you don't catch the exception, bad things, right? The program ends. And it's not a crash, even though we like to say that the program crashed, but it might as well be. It's an unhandled exception. Bad. Now, in some other languages, every method says what exceptions it might raise. And so you can really prepare in advance, but Python doesn't do that. And so to start preparing for worst possible situations for all method calls, for all parts of our code, that's just going to be a lot of work just to make sure that we don't encounter any warnings that are trying to prevent bad things from happening. So that's like one extreme that we could use exceptions. Another extreme, the other extreme is to use print, right? We use print all the time. We use it for debugging. We use it for displaying things on the screen. The problem is that print is just not serious. It's not scary enough. It's so easy to say, yeah, whatever. I'm going to ignore that for now. But there's some other issues as well. The output will get mixed up with regular program output. So what's actually coming as a warning and what's coming as regular output, it will be hard to distinguish. And we also want our software to be able to distinguish it. So we can filter or trap messages. And if it's just coming as text with print, that's going to be really hard to do. So given all this, how can we use warnings? How do they actually, what do they look like and how do they work in Python? So here's an example. The example is basically, let's say I have this function, def hello, takes the argument name, parameter name, and returns hello name. Now I plan to change this function in the future so that it takes a list of inputs rather than a single string. And what I want to point out here is that I'm making an incompatible API change. I'm changing my function so that anyone who's using the previous version will be out of luck. And so I need to somehow get the message out to people, hey, things are changing. If you don't change your behavior, bad things will happen. Now, how can I do that? Well, I could write it in the documentation, but let's be honest, who's actually going to notice? I could put it on an issue in GitHub. I could announce it on a website. I can do all sorts of different things. But the sad fact of the matter is that there's so many developers out there using so much code that expecting them to read documentation and notice these things, it's just not that likely. There will be people who will keep track of what's new with each version and what has changed and what breaking changes there are. And yet, a lot of people just will not. So what we're going to do in our function is we are going to add a warning. And here's what the warning looks like, right? So in order to get this to work, I'm going to need to import the warnings module. Now, there was actually discussion in the PEP, the original PEP from 20 years ago, shouldn't warnings just be in built-ins? And the decision was no, actually. I mean, it's not that hard to import warnings. And anyway, the people who are going to be doing this are developers, so we're okay with that. So you import warnings in order to send warnings to the warning system. You then invoke, there's basically one function, warnings.warn. That is how you indicate there are warnings in Python. That's how you generate a warning. It's sort of kind of like raising an exception, except of course it's not. It's lighter weight than that. It's a little different. And then of course we have a message. And this is again similar to what we would do with an exception. I say that here's my warning, coming soon, pass a sequence of strings. Now it should probably be a little more explicit and nicer than that, but I was trying to keep it on one slide. Now what happens when I run the program? So I run this program here, right? I define the function, and I'm going to run a program that's going to say from hello, import hello. So it's going to go to the hello module, import the hello function that's going to run hello world. Now what happens when I run use hello.py? I get this. And now notice the different pieces that come together here. We get the file name and the line on that file from which the warning was generated, which means basically that if I'm not sure where it came from, I can trace it back right here. And not always is it super obvious where a warning was generated. So having this information is really, really useful. The next thing is we have what's called a category of warning. And this is, I would say, analogous, except it's not even analogous. It's a subclass of a type of exception. Warnings are exceptions, but they're treated specially by the system. And so if you were to go look at user warning, you'd find out, yeah, it's inherits from exception. This is the default type of warning that you'll get if you don't specify otherwise, as we saw. And here's our message. And you can even say where it says warnings.warn now, although obviously. So that's great. We're running warnings, we're getting it, and whoever sees the warning will know what to do. Notice also that hello world is still printed. So the warning is not stopping the program. It's not interrupting the flow of the program. All it's doing is printing out a message, and it's printing it to standard error, I should add, so that if someone wants to know that it's there, that's great, right? But the program is actually going to keep running. And as I just mentioned, the output does not go to standard output. It doesn't go to standard output, it goes to standard error. Now on your screen, standard output and standard error are sort of mixed together because it's like on the same screen. But if you were to redirect the output from the program, let's say use hello.py greater than hello.txt, so we will still see the warning messages on the screen, even if the output from the actual program, the standard out, is redirected to hello.txt. So this means that you're going to have to do something to use warnings that you might not want to do. And that means plan ahead. If you don't plan ahead, then you're not going to be able to give warnings to your users before you change the API, before you make other big changes to the program. So warnings are there in advance, and that means you're going to need to give them a heads up. If you can give them a heads up 1 or 2 versions in advance, all the better. And the core Python developers have to be really good about this. It's extremely rare for something to suddenly change and be a breaking change in a version of Python. If things break, it's because, as we saw earlier with the mapping loading, with the import of mapping there, it's very good. Like the Python community is good at doing this slowly, giving you some time to know, oh, this is going to go in the future. It's going away in the next version. It's going away this version. It went away. So give your users some time to transition and make sure that you give them several versions in order to deal with it. Now, I mentioned earlier that user warning is a category similar to an exception class. And the purpose of having different kinds of warnings is actually twofold. Number one, the semantic power. We as programmers would like to know the differences between different types of warnings. It's not all one type of warning. Some of them are worse than others, and some of them are sort of more interesting than others, at least to our particular development capabilities. But it also means that we can put in some automated detection and filtering. We're going to see how to do that in a little bit. And as I mentioned, warning categories actually are exception classes. How do I know this? Well, if I go to user warning and I ask, what does it inherit from? What are its bases? I'm told, oh, well, that's a class warning, right? So user warning inherits from warning. And what does warning inherit from? It inherits from exception. So warnings are exceptions, but they are, as I've mentioned, handled specially and separately from the system. Now, there are already a bunch of warning categories that come built in with Python. There's warning, user warning, deprecation warning, syntax warning, runtime warning, and pending deprecation warning, among others. And a bunch of these are pretty obvious as to what they're for. So by default, we saw that it's going to give you a user warning. But if you want to specify some other type, you can do that. How do I do that? Well, I pass a second argument to warnings.warn, and that is a category, one of these warning categories that we have there. And then when we do that, when our warning is actually displayed, it's going to indicate what type of warning it was. Now, the thing is, if we run the code on the previous slide, there won't be any warnings. I'm just going to go back there for a moment to show you. So in this code, we are saying warnings.warn, coming soon past the sequence of strings, deprecation warning. The only difference between what we saw before, which did display a warning, and what we're doing now is this, the deprecation warning. And that's because deprecation warning is filtered out by default, so it won't appear. And we're going to talk more about filtering in a little bit. But you should just know that it's possible to make things appear and disappear. And quite frankly, I find it a little surprising that deprecation warnings are filtered out by default. Like, wouldn't people want to know that? Until you understand why they're filtered out by default. Because if I have my program and I use a module, let's say a package that I downloaded from PyPI, and that package is getting deprecation warnings, do I really want to know about its warnings? Right? I can't fix that code, or I'm not the owner of the code at least. So in order to stop regular end users from seeing warnings for things they can't really fix easily, they made the deprecation warning filtered out in almost all cases. Well, when we're raising exceptions, it's usually considered to be a good idea to use your own custom classes rather than the built-in exception classes. If you are raising type errors, value errors, you're probably doing something wrong. And in the same way, you probably should be using your own custom warning categories. And the idea then is what you're going to be able to do is filter based on those, and also just the user will see that it's something different. And then you can be really specific about the type of problem and not just say something like user warning. Now, your new warning should subclass an existing warning type. And the reason is not only because it solves all sorts of problems of inheritance, but you can take advantage of inheritance then. If you're a subclass of, shall we say, deprecation warning, then you are a deprecation warning in addition to being something else as well. And all the rules for deprecation warnings will then affect you. So how can I create a custom warning? It could not be easier. I just define a new class. Class argues_changing warning, and it inherits from user warning. And then I can just use that, right? And pass, I should say. Like, we don't care about the contents of the class. The reasons for defining this class have nothing to do with what methods it has and what state it has. They have to do with the fact that we want this semantic power to be able to distinguish between warning types. And then, as a second argument, I just pass argues_changing warning. Now, what happens when we are warned? Well, we've seen that generally a warning will be sent to standard error, except we also saw that sometimes nothing is sent to standard error. That's because we can customize what happens to warnings. And we can customize what happens to particular categories of warnings. What do I mean by that? Well, Python has a warnings filter, and you can say what should be done for a particular category of warning and its message contents, and even the module and the line number it's in. Let's take a look. So the default filter says, we're going to print a warning the first time it appears in a given file on a given line. So let's say I have a function that produces a warning, and I call that function once, well, the warning is going to show up. But if I call that function twice, it's not going to show up the second time. Right? But if that same warning appears in multiple places in the code, then you will see multiple messages, once for each call to warnings.warn and once for each different line number. So this is the example I was just talking about. Let's say I say from hello, import hello, and then I say print hello world 1 and then print hello world 2. If we have the default behavior, then what we're going to see here is we're warned once, because the default behavior is to warn you only once per module per line, even though the function was called twice. So the function has warning.warn in it, and it was called twice, but we're only going to check it once there. So how can we change this? Well, we're going to have to indicate what the action is we want for a particular category. And there are actually 6 different actions we can give. Default is what we've seen, once per combination of module line number. We can say error to turn to an exception. We can say ignore to ignore the warning. And we can say always, meaning always print. I don't care how many times I get that. I just want to do it again. Now, always might seem like the best way to do it, but it gets really annoying to get the same warnings again and again when you just want to concentrate on your code. Okay, I saw the warning, I'll deal with it. Ignore can be dangerous, but it can also be useful. You can basically say, I don't want to think about a certain category of warning. And error, as I mentioned, means raise an exception, turn this warning into an exception, and thus someone needs to trap it. We also have module and once for different sort of frequencies. I only want to print once per module, and I want to print once for each warning. Okay, so let's say we want our exchanging warning to be displayed every time it occurs, no matter what. That would be the always option. How can I set that? Well, we can actually set the filter for warnings on the command line. When we call Python, it's Python space minus big W and then an action. And each action, each of these 6 that I mentioned just now, starts with a different letter. So you can abbreviate just down to one letter. That is fantastic. So look what I can do. I can say Python 3 minus big W always, use hello 2. And then it's going to warn me twice because I've said that all warnings should always be displayed. So that's what we get. The thing is, I might want to be a little more specific than that. I might not want to make all of them always. I might want to make always for some categories and other actions for other categories. So the filtering lets us find not just the action, but also the message. And that's a regular expression match of the case-insensitive message. And it's only the message started checks on, so don't go look in the middle. Then a category, and then a module, and then a line number. You can search on any or all of these and assign it then, well, you can assign a particular action to a combination of any of all of these. And you just pass these separated by colons to minus big W. And you can even pass minus big W multiple times to get multiple filters. So let me give you some examples here. So to give a deprecation warning, an always action, you're going to say minus big W action, colon, colon. Between those 2 colons could be a regular expression to search the first part of the message, but we're not going to do that. And then deprecation warning. So now every deprecation warning is going to show up ad infinitum. What if I want to make deprecation warnings visible, but only if the message begins with an A? Well, then I put an A between those 2 colons there in the middle, because it's action, and then the match, and then the category. I can also just say, anytime we encounter a Unicode warning, I want to turn that into exception. I want to make sure that it, I don't know, kills off the program, but it has to be trapped. It's too serious to let go. So these are the default filters that are in place. And you'll see then that on the second line, deprecation warning is always ignored. But on the first line, before that gets put in, we say, actually, we're going to have the default behavior for deprecation warnings in dunder main. So if you're getting a deprecation error in your main program, and the first thing that you run from the command line, then yeah, it will appear. It'll appear once because of the default. But if you are not in, if the deprecation warning doesn't happen in your main file, it happens in something that you imported, then we will not see it all being ignored. And that's basically to solve that problem that I mentioned earlier of how can I deal with these problems? Like, why am I getting deprecation warnings when I'm not the author? And then we have pending deprecation warning, and import warning, and resource warning. This means that we're going to ignore a whole bunch of different kinds of categories. You could also, by the way, set the Python warnings environment variable. And then if you do that, then we've set the first one, we're going to get an exception for deprecation warnings. The second one, we're getting the default for resource warnings. So that's all great. There's just one problem with what I've described to you so far, which is we cannot use them to trap for custom warning categories. And that's because the custom warning categories are being loaded into Python, right? We're importing hello.py, for example, after the warning categories have already been described. And so the variable's not found, or the class is not found, it's going to give us an out. The thing is, we can filter also from within Python. So if I call warnings.filter warnings, that's like the most generic, and I can set all 5 filter elements. But I can also use just warnings.simple filter, which is so much easier to use. Then I just specify the action, category, line number. I can also call warnings.reset warnings, which says, you know what, let's just like throw out all the warning filtering that we've set up so far. So for example, if I say here, import warnings, and then I'm going to say from hello, import hello and args changing warning. I'm importing our custom category so that we can refer to it by name. And then I'm going to set the simple filter. I'm going to say, hey, when we get args changing warning, I want to use the default. And then when we run our program, it'll only show once because of the default. There's also this really cool context manager that lets you temporarily change the warning settings. So if the filters were set to some, all sorts of crazy things, and then you learned about catch warnings, what you can do is you can temporarily set those others aside. Inside of the with block, you can then apply warnings.simple filter to do what you want. And then you can call some sort of function that you know is going to generate a warning, but you want to just ignore it. So this is how we can generate warnings. This is how we can get warnings and filter them. But one question remains, which is, where should we use warnings? Where should we be warning our users? So one place is wherever you're going to be making extensive API changes. So is a module going away? Are its functions making extensive changes? You can put warnings.warn at the top of a module. Remember that when you import a module, the module is actually going to be executed. And so you can put in warnings. Now, it might seem a little, in poor taste to have warnings.warn running inside of a module, not in if name equals main, just like there in the module. But you have to sort of protect yourself, and you want to warn your users, as it were, of what's coming down the pike. And remember that deprecation warning is ignored by default if it's not in dunder main. So if you want to use deprecation warning, that's fine. Just make sure to turn it back on so you're not going to have trouble. What else? Well, maybe you can notice common mistakes. So if people call a function with the wrong arguments, and you can notice this, try to use a warning, a warning to point them in the right direction. So some examples. So the pandas library, perhaps the most infamous warning there is setting with copy warning. So it notices that you're assigned to a copy that's not going to go back to the main data frame, and that this is a bad idea. It even gives a URL to the documentation describing what's going on and how you can fix it. So that's like really useful. I mean, people hate this warning. People hate this warning because it's so annoying. And yet, it's really important to understand it. And so it comes up. Two warnings that have gone away. One of them is that in scikit-learn, if you try to run predict on a one-dimensional list or array, it would say, hey, you should really be giving me a two-dimensional array, like an array of arrays. And now it just is an exception. So you used to get some just to get off with a warning, as it were. And now, nope, we've passed that time. It's been a while already. If you pass the wrong data type, then we're just going to blow up. Similarly, and even further back in the past, Python 2 would warn you if you use global after a variable assignment in a function. So if I open my function, I say x equals 5, then global x, Python was like, what do you want me to do with this? It would keep it as global, but it would get upset. And nowadays, you actually cannot do that. You get an error. And so I would say these last two examples are perfect examples of where warnings were a good idea. Because basically what it means is we're telling people this is going to change. You are going to suffer. And so, here's how you can deal with it. And so afterwards, after giving the warning for a while, then it became a fatal error. So let me go back to my example from before, because let's say you're driving and the fuel tank looks like it's close to empty, but you don't quite believe it. And then the yellow light goes on and you're like, I really probably should get to a gas station at some point soon. Yeah. Well, guess what? There's another warning in there. And that additional warning is if the gas is almost out, then the fuel gauge is going to read E and the yellow light is going to go on, and then it starts, beeping. And believe you me, if you hear that beeping, that's a serious warning. You know that you better take care of it, or you're going to be stuck on the highway without any gas. Okay, I hope that this was a helpful, useful talk. Please contact me. I'd love to hear from you via email, Twitter, on my website, and you can even join my free weekly Better Developers newsletter, currently read by about 20,000 Python developers all over the world. Thanks so much for watching and for listening, and I hope to be able to chat with you now in the forum.